afternoon. My name is Melchior Amons. I'm with Juniper Networks, and one of my roles in the company is to try and convince customers and others to implement routing security. So I talk a lot about RPKI, and today I would want to talk about another, I think, important matter with regards to BGP security, which is called the TCP authentication option. And you might wonder why now, and because the RFC was written 10 years ago, but I think it's now time to start replacing MD5 with TCP AO. So let's go into why do we actually need TCP security. What we're trying to protect is long-lived TCP sessions. Examples of those are BGP and LDP, but other long-lived TCP sessions could, for example, be RPKI RTR, which is definitely something I think should leverage TCP AO next. So we're trying to protect these sessions against blind insertion attacks and replay attacks. And to go quickly into what is a blind insertion attack, that is something that could, for example, happen on a shared LAN, for example, on an Intel exchange. So let's assume we have two BGP speakers, router A and router B, and they maintain a what we call long-lived TCP session that maybe is there already for hours or longer and exchange routes. However, on that same LAN, there is a router C, and router C would love to see that BGP session go down. In order to do that, he's trying to bring the TCP session down. So what node C does is it sends a few packets every second to router B for many, many hours, and it tries to do that with a spoofed source address. It uses the source of router A, and it has a TCP payload with the reset bit set. Obviously, as it's BGP, it tries to connect to TCP port 179, and it tries to guess the right sequence number. Obviously, this won't have any effect, because as long as the sequence numbers won't match, B will obviously discard the packets. However, at one point, router C will probably guess the valid sequence number, and as it has the TCP reset bit set, it will be able to reset the BGP session. So we have MD5 for that, right? MD5 is widely deployed, widely spread, used a lot, and did a pretty good job. So how did MD5 work? Very briefly, sending and receiving nodes are configured with a pre-shared key, and that key was used to calculate a so-called message authentication code for each TCP segment. It uses the MD5 a mechanism to calculate that MAC, and based on the pre-shared key. And then the receiving node would calculate the MAC for each received segment. And obviously, if the calculated MAC does not match with the MAC it receives, it will discard the packet. So far, so good. However, over time, the requirements changed. One of the issues with MD5 is that, for example, it doesn't allow for dynamic key rollover. So if you change a key, it'll reset the TCP session. And MD5 won't support the use of multiple and perhaps newer authentication algorithms. So in practice, no one ever changes the pre-shared key for MD5. And obviously that's not a situation that is preferable. So 2016, June the 5th, Ron Bonica presented at NANOG 37 a new idea, which was called authentication for TCP-based routing and management protocols. It took him another 4 years until he published the RFC. And in 2018, Ignas presented at NANOG 73 a lightning talk where he was basically trying to figure out why TCP/AO wasn't implemented yet or used yet. And the main reason was obviously because there were no implementations. That all changed because it's actually now 3 vendors, Cisco, Nokia, and Juniper, who have the code in production. And so here we are, October 19, NANOG 80, me trying to convince you to replace MD5. So how does the TCP authentication option works? And why is it useful to replace MD5? Basically, the 2 most important things, obviously, are that it does support key rollover without resetting the TCP session, and it supports multiple authentication algorithms. So we just quickly looked at how MD5 worked. Now let's see how TCP/AO works. In TCP/AO, you have the option to configure multiple MKTs, master key tuples, which are in, for example, Juniper's implementation, you're able to configure up to 64 of those keys. And they're used to derive the traffic keys. The traffic key is then used to calculate that message authentication code for each TCP segment. The RFC also introduces a new type, which you can set in the TCP header. That's the TCP authentication option. And so the MAC, message authentication code, contains a key ID, so you know which key to use, and the received next key ID. So the other side knows the next packet will be using this next key. The key ID identifies the master key tuple, so the other side knows that that one is used to generate the MAC. And so how does the master key tuple look like, or what's the content? Basically, a TCP connection identifier that's built out of the source address, destination address, source port, and destination port, and wildcards are allowed. It sets the TCP options flag to determine which TCP options are covered. And the identifier, as I said, the sending identifier used to generate the key ID on outbound segments, and the receiving is used to resolve the key ID on the inbound segments. You pick a authentication algorithm, you pick or you have key material, so master key, and obviously a key derivation algorithm. So traffic keys are 4 traffic keys are derived from each MKT, as we already mentioned. And then this is how it looks like. So we set the type kind to 29. So the receiver knows that TCP authentication option is active. The length, we set the key ID and the received next key ID. And obviously one of the biggest advantages is that it allows for variable length of the MAC, because that allows for different algorithms, and even allows for future algorithms. So how does keying in TCP/AO works? Again, each node is configured with 1 or more master key tuples. Each node derives 4 traffic keys from each master key tuple, and each node independently determines which MKT is active. How you define that, which key to use at what moment, isn't described in the RFC, but most implementations, so Juniper, Nokia, and Cisco, all use a start time and an end time for each master key tuple. And the interesting thing here is that there can be an overlap between the end time and the start time. So in other words, we don't have to synchronize the time. As long as we're in the same window, we're okay. So that allows for easy key rollover even without having to schedule a maintenance window and people synchronizing exactly at the same moment. So the authentication part, again, we calculate the MAC for each TCP segment using the appropriate authentication algorithm. Then we calculate the MAC over the TCP segment and the active traffic key. And we include that in each segment, and the receiving node obviously goes the other way around. So it also calculates the MAC for the segment that is about to receive. And obviously, if the MAC doesn't match the MAC it expects, then it'll discard the packet. So, as I already mentioned, there's currently 3 vendors who have running code and code available. That's Nokia, Cisco, and Juniper. The Juniper code was actually released, I think, 2 weeks ago, so that's pretty new. We got a commitment from Huawei that they're targeting for second quarter 2021. And obviously, we did some IO testing with the code that is available. So Nokia and Juniper both did IO testing. If you're interested in that, follow the GitHub links, github.com/tcp-AO. You'll find some configuration examples there and some more info on the IO test. And there's an episode of the Routing Table podcast starring Ron Bonica and Greg Hankins, who discuss why TCP-AO now, how that IO test went, etc. So that's an interesting listen as well. One of the remarks we got, or objections to AO, was basically, but we already have GTSM. True, GTSM protects obviously eBGP sessions by having the sender set the TTL to 255 and the receiver obviously expects nothing less than 245. That works brilliantly. However, on a shared LAN like an internet exchange, obviously others can also send packets with a TTL that's set to 255. So you would still need an additional protection, like for example TCP-AO. And obviously AO or a GTSM won't protect iBGP sessions for against internal attacks. And as good practice, I would definitely recommend to not rely on just a single security mechanism. So a little bit on that IO testing I just mentioned. So Juniper and Nokia at one point, thank you Greg Hankins, decided to IO test. However, at the same time, COVID-19 kicked in. So a physical test, or at least shipping physical equipment and getting people on site, was really hard. So we decided, why not try to do this over the internet? I mean, everyone has virtual appliances these days, so why not set it up over the internet? And that actually worked quite well. So IO testing, especially if it's on protocol side, can easily be done over the internet. And there's some lessons learned. You have to configure different send key and receive key opposite as to the other side. If you configure that likewise on both on the same, then obviously the session won't come up. So that took some time, but obviously it did show that it worked. And of course, as you can see in yellow, the algorithms need to match as well. And you see, if you take a close look, that there's different start times and begin times used, and that emphasizes what I was just talking about, that it's not that strict that you need to be exactly on the same time. Another thing we learned, and that this took quite some time, is that when we started testing the session didn't came up, so the packets were not accepted. Turned out that on Juniper side, there was a firewall active that changed the TCP MSS option. So when we figured it out and we bypassed the firewall, it all worked brilliantly. In other words, TCP AO protected us from establishing a TCP session with where the TCP MSS option was changed. I also have a call to action. As TCP AO is quite new, I would definitely want to ask people to start testing and playing around with it. Both Juniper and Nokia can provide virtual labs to test, so please do reach out to either Greg Hankins or myself if you're interested in testing. And we can even get you access to the virtual license so you can test between vendors. Ask your router vendor for implementation statuses. As I mentioned, there's 3 vendors who have the code implemented, but obviously there are many more vendors. And if you're a developer, there's a lot of work that still needs to be done. For example, what would definitely help drive adoption is if we have support in tools like TCP dump, Wireshark, but also if we can get the kernel code done for Linux and BSD. Ignas is, for example, working on that as well, and he could definitely use some help. And obviously, if you are a BGP developer for Bird, FRR, etc., if you're interested, please do reach out. And with that, I would ask you to start replacing MD5 with the TCP AO option. If you have any questions, feel free to ask them now, or else reach out to me via email, Twitter, and LinkedIn.
Thank you, Melchior. That was very interesting. We didn't get any questions in the channel, so I'm going to ask you one. If I wanted to start implementing this myself in my lab, what vendor OSs and what versions of them actually support it right now?
Yeah, so currently there's 3 vendors who have shipped the code. So that's basically Nokia, Cisco, and Juniper, where it's supported in Nokia XR since 6.6.3 and 7.0.1. And Nokia and Juniper tested with the Nokia release 20.5 R1 against I think just 2 or 3 weeks ago released the Juniper code that's 20.3 R1. And so we also got a, let's say, promise from Huawei that they're targeting for second quarter 21 to ship the code. And we reached out to Arista as well, but they unfortunately wouldn't commit on timelines yet. But yes, as I said, the most important thing now as well is to have running code for BSD and Linux, obviously. So the open source BGP implementations would support AO as well. But yeah, you can test with either the virtual appliances from the 3 vendors I mentioned, or upgrade your physical routers if you feel adventurous.
Great, thank you. And we do have a question from Rudiger Volk asking, are you aware of any work on standardizing the key management, perhaps using Yang?
Yeah, excellent question. So the TCP AO RFC doesn't describe key management, obviously. We discussed amongst a few folks maybe to start writing something or submit a draft to IETF in order to get that in place as well. So I would definitely want to invite Rudiger to join that effort.
And another question from David Farmer asking, is there any work going on in peering DB or any other mechanism to find people willing to peer using TCP/AO?
Yeah, excellent remark. I haven't myself discussed that with the folks at peering DB yet, but yeah, I would definitely be interested in having the chat and see how we can leverage the, let's say, PeeringDB database for maybe doing key distribution or key management, because that would definitely be an interesting option.
Okay, that's it for our questions. Thank you very much for being here to speak with us, especially considering it's nighttime where you are.